In the compounds of group 16, we have started with preparation method of O2. Most important property of O2 is it is paramagnetic, which can be proved by MOT, molecular orbital theory. Preparation methods में electrolysis of H2O2 or H2O. In electrolysis में, if you are doing oxidation of H2O2 and H2O, you will be getting O2. Oxidation मतलब loss of electrons, which always happens at anode. Reduction will always happen at cathode. So यहाँ पे oxygen जो -1 oxidation state में है, if you are removing electrons, it will be converting into 0 oxidation state, or else it will be forming O2. Similarly, H2O का भी -2 oxidation state में जो है, if you are removing electrons, it will be forming O2. So electrolysis of H2O2 or H2O, you will directly get O2. This is very important. Heating of potassium chlorate, KClO3. Whenever you are heating that, in general, the temperature that is going to be required for the decomposition of this is very, very high. So if you want to decrease the temperature, we need to add a catalyst, which is MnO2. So in the question, they will ask you the catalyst used. The catalyst used is MnO2, which will decrease the temperature of the reaction. All metals can show self-stable. So whenever you are heating them, they will be converting into metal as well as O2. So how you can remember these are all the metals which are extracted using self-reduction. Self-reduction में हमने किया क्या है? If you are having a sulfide ore, initially you will be converting that into an oxide ore. That oxide ore or the oxide form reacts again with sulfide to form a metal in the pure state as well as the other product. Okay, give me 2 minutes. Okay, उसके बाद heating reactions of KMnO4 and K2Cr2O7 are very, very important. Similarly, heating reaction of ammonium dichromate, which will lead to the formation of N2. Heating reaction of ammonium carbonate, which will lead to the formation of NH3. वो heating reactions भी important है. As I suggested, everyone please mark all these reactions in a separate page, तब आपको याद रहेगा. Okay. Oxides, upon heating, PbO2 converts into PbO and O2. यहाँ पे Pb का what is the oxidation state? +4. Lead का +2 oxidation state is more stable when compared to +4. Hence, whenever I am heating it, it is easily converting into PbO and O2. Okay. Pb3O4 में आपको again the oxidation state of Pb is +4. It is combination of PbO as well as PbO2. So if you are heating it, it is converting into PbO and O2. Mn3O4 converts into MnO2 plus O2. All nitrates upon heating, all nitrates इनमें except group 1 nitrates. Group 1 nitrates में आपको lithium nitrate जो है, it will also give you NO2 and O2. Okay, except group 1 nitrates, rest all other nitrates will be giving you NO2 plus O2. Okay, NO2 तो सब में मिलेगा, sorry, NO2 नहीं, O2 तो सब में मिलेगा. Nitrogen dioxide जो है, it will be formed only by heating nitrates other than group 1 nitrates. Okay, group 1 nitrates में lithium nitrate जो है, it can form NO2 and O2 because of its diagonal relationship with magnesium. Okay, because of the diagonal relationship with magnesium, it is able to form NO2. बाकी सब nitrates जो है, whenever I am heating them, they are converting into nitrite and O2. NO2 नहीं मिलेगा. Okay, but यहाँ पे तो preparation method of O2 है, so if you are heating any of the nitrates, you will be getting O2. Is that clear? Okay. उसके बाद ओजोन देखा है, ओजोन का preparation method देखा है हमने. उससे पहले we have also seen the dissociation of O3 with the help of UV light. Whenever O3 is interacted with UV light, it converts into O2 as well as nascent oxygen. That nascent oxygen reacts with NO present in the atmosphere to form NO2. This NO2 further reacts with another molecule of O3 to form NO3. That NO3 will be combining with NO2 to form N2O5. यहाँ पे sequence of reactions लिखा है आपको मैं. NO, you can show that reaction either with nascent oxygen or you can show the reaction with O3 in the presence of UV light, which will lead to the formation of NO2 plus O2. This NO2 will again react with O3 in the presence of UV light to form NO3 plus O2. ये जो NO3 है, it will be reacting with NO2 to form N2O5. This N2O5 upon dissolution in water will be producing HNO3, which is nothing but acid rain. Okay, you can also mix this NO2 in water. It will be producing HNO2 plus HNO3. Hence, NO2 is called as mixed anhydride. Remember? Okay. Preparation of O3. This is very important preparation method. O2 under silent electric discharge converts into O3 and the reaction is exothermic. O3 is very strong oxidizing agent because it converts readily into O2 and nascent oxygen. Hence, it is treated as strong oxidizing agent. So यहाँ पे reactions of O3 as an oxidizing agent देखा है. Oxidizing agent मतलब खुद reduce होगा, बाकी चीजों को oxidize करेगा. If you are having PbS where the sulfur is in -2 oxidation state, it is converting into PbSO4 where the sulfur is going into +6 oxidation state. Okay, so it is getting oxidized. I- जो है which is in -1 oxidation state, converting into 0 oxidation state initially, which on further reaction with the O3 converts into +5 oxidation state. This particular reaction is used for the estimation of O3, which is done by the estimation of I2 with the help of hypo, sodium thiosulfate. Whenever the I2 is formed or if it is passed through sodium thiosulfate, it will be converting into sodium tetrathionate. This is called as sodium tetrathionate plus NaI. So equivalence of I2 reacted must be equal to the equivalence of Na2H2O3 reacted, which will be further equal to equivalence of O3 reacted. So indirectly, this reaction is used for the estimation of I2 or the estimation of O3. Okay, remember this. ये वाला part याद रखना important है. Fe2 positive converts into Fe3 positive. Just remember, O3 is an oxidizing agent. If it is an oxidizing agent, it will oxidize others. So you need to take their respective oxidation states into their higher oxidation states. +2 converts into +3, +2 converts into +4. NO2 में ये +4 oxidation state में है, converts into +5. ये reaction already देखा हमने. NO2 जो है पहले O3 के साथ react करके O2 plus nascent oxygen. That nascent oxygen reacts with NO2 to form NO3. That NO3 again reacts with NO2 to form N2O5. Okay, यहाँ पे ये वाला reaction. Okay, उसके बाद हमने सल्फर के बारे में स्टार्ट किया है. Sulfur exists in different forms: S8, S6, S4. S8, S6, S4 are diatomic. S2 is paramagnetic. Sorry, S4, this is diamagnetic. S2 is paramagnetic. And the paramagnetic nature of this can be proved by MOT again. Okay, remember S2 and O2 are paramagnetic. Okay, it can exist in different allotropic forms: rhombic sulfur and monoclinic sulfur. Whenever you are heating rhombic sulfur, it converts into monoclinic sulfur. Whenever you are cooling it, it converts into rhombic sulfur. Okay. S8 or S6, out of S8 and S6, S8 will be a more stable form because of its ground structure or because of the greater bond angle between two bonds. S6 has chair-like structure. This structure is having an angle of 102 degrees. So repulsive forces will be greater when compared to here. So chair structure is less stable form of sulfur when compared to the ground structure. Any doubt? Okay. उसके बाद ये रिएक्शन यहाँ पे जो भी लिखा है, रिएक्शन ऑफ सल्फर विथ NaOH, रिएक्शन ऑफ फॉस्फोरस विथ NaOH, रिएक्शन ऑफ क्लोरीन विथ NaOH. फॉस्फोरस में दिस इज द रिएक्शन ऑफ व्हाइट फॉस्फोरस विथ NaOH. I hope you remember this, which is the disproportionation reaction. Any of the reactions of these non-metals with NaOH are disproportionation reactions. ओके, कहाँ तक सुना है आप लोग?
वो डिस्प्रोपोर्शनेशन।
ओके ओके, ये जो 3 रिएक्शंस है NaOH का with non-metals, NaOH with Cl2, NaOH with phosphorus and NaOH with sulfur. Remember these 3 reactions separately, very very important, more probable for asking in entrance exams. Okay, फॉस्फरस के साथ आपको फॉस्फीन प्लस NaH2PO2 मिला है। ये जो NaH2PO2 है, it is salt of H3PO2. H3PO2 is called as hypophosphorus. Okay, so उसका salt जो है, this is called as sodium hypophosphite. सोडियम हाइपोफॉस्फाइट मिला है आपको और PS3 फॉस्फीन मिला है। फॉस्फीन हैज रॉटन फिश स्मेल। ओके, Cl2 के साथ you have 2 different reactions, cold के साथ और hot के साथ। With cold it is converting into NaClO, sodium hypochlorite and NaCl। यहाँ पे आप लोग और एक रिएक्शन भी हम आगे जाके देखेंगे। rather than reacting that with NaOH Cl2 को, if you are simply dissolving that in water, you will be getting HCl plus HClO। यहाँ पे जो NaCl और NaClO मिला है ना, वैसे यहाँ पे HCl and HClO मिलेगा। This on reaction, ये HCl और HClO NaOH के साथ रिएक्ट करके, अगर सॉल्यूशन के अंदर NaOH भी रहता तो, the solution being basic, these two being acids, इन दोनों के बीच में रिएक्शन होके आपको सॉल्ट बनेगा, NaCl salt as well as NaClO. Is it clear? NaClO is called as sodium hypochlorite. If it is reacted with hot, if it is reacted with the hot NaOH, in that case you are getting NaCl plus NaClO3, which is called as sodium chlorate. This is sodium chlorate. NaClO is sodium hypochlorite. Okay. Next, sulfur का disproportionation reaction, NaOH के साथ reaction करने से आपको you are getting sodium thiosulfate as well as Na2S. Sodium thiosulfate में उसका oxidation state +4 है, यहाँ पे -2 है, so 0 converting into -2 and +4, +6 है क्या यहाँ पे final oxidation state? Sorry, it is +4 only, +4. So -2, 0 converting into -2 and +4, which is disproportionation again. Is that clear? Okay. Okay, I'm sorry, यहाँ पे oxidation state मैं ये देख के मार्क किया हूँ। Individual oxidation state of sulfur is +2. ऑक्सीजन नेट में -6 है, सोडियम इज +2, सो 2 सल्फर्स का मिला के +4 है, हर एक सल्फर का ऑक्सीजन स्टेट है +2। ओके, ठीक है। सल्फर विथ कॉन्सेंट्रेटेड H2SO4 gives you SO2. सल्फर विथ कॉन्सेंट्रेटेड HNO3 gave you NO2, राइट? वहां पे NO2 मिल रहा है, यहाँ पे SO2 मिल रहा है। Most of the reactions of sulfur you will be liberating SO2 rather than SO3. Okay. Okay. Concentrated HNO3 के साथ you got, देखो यहाँ पे NO2 with O2 you will be majorly forming SO2 and you are having traces of SO3. Is that clear? Okay. Acidic strength SO3 is greater than SO2 करके लिखा है। Reason, अगर SO3 को पानी में मिलाया, what is the acid you are going to get?
H2SO.
You will be getting H2SO4. SO2 को पानी में मिलाया, what is the acid you are going to get?
H2SO3.
H2SO3. H2SO4 is a stronger acid when compared to H2SO3. Okay, hence SO3 will be more acidic when compared to SO2. Or else, whenever you are comparing the acidic strength, if the positive oxidation state increases, जितना ज़्यादा positive oxidation state रहेगा, उतना ज़्यादा acidic होता जाएगा. Is that clear? Okay, next, SO2 के preparation method. Simple reaction of oxygen with sulfur, you will be getting SO2. If you want to convert that SO2 into SO3, you can use a catalyst V2O5. This particular procedure, जो भी ये reaction है, it is used in the preparation of sulfuric acid H2SO4. Contact process में रहता है ये equation. आगे देखेंगे. So simple reaction of or oxidation of sulfur with O2 or reaction of sulfur with O2 will be giving you SO2. Any doubt? Okay. Industrial preparation method of SO2. If you react FeS2, which is also called as fool's gold, मतलब gold जैसा दिखता है, but this is not gold, FeS2. Whenever it is reacted with O2, you will be getting Fe2O3 plus SO2. And the preparation method, which is industrial preparation method. So this is also an important reaction. Laboratory preparation method. If you are treating sulfide with H positive, this will be converting first into H2SO3. H2SO3 being unstable converts into SO2 plus H2O. Just like H2CO3 जो है, it being unstable converts into CO2 plus H2O. वैसे ही H2SO3 जो है being unstable converts into SO2 plus H2O. Next, this is also an important reaction, green vitriol, which is FeSO4.7H2O. इसको हीट करने से भी आपको SO2 मिलेगा and you'll be having some traces of SO3. Is that clear? Okay. Next, ये जो P block chapter में reactions of O3, reactions of SO2, both the reactions are very very important, and both of them, ये जो SO2 जो है, O3 is oxidizing agent, okay, because it is giving nascent oxygen. SO2 जो है, it is reducing agent. If it is reducing agent, खुद क्या होगा? Oxidize होगा. Oxidize मतलब loss of electrons. Already it is in +4 oxidation state. So the +4 oxidation state will be converting into +6 oxidation state. Whenever it is acting like a reducing agent, SO2 में +4 oxidation state जो भी है, it converts into +6 oxidation state. तो यहाँ पे आप लोग देखा तो SO2 on reaction with Cl2, simple addition कर लिया है यहाँ पे, SO2 Cl2 हो गया, which is sulfuryl chloride. If you are having SoCl2, it is called as sulfonyl chloride. यहाँ पे if you observe the oxidation state of sulfur, SO2 Cl2 का structure S double bond हो, Cl और Cl, sulfur being less electronegative, यहाँ पे इसके ऊपर +6 आएगा. So sulfur has converted from +4 oxidation state to +6 oxidation state. Any doubt? Okay. SO2 with O2, further reaction with O2 will be converting into SO3. SO2 with PbO2 converts into PbSO4, which is heavy white precipitate. Again, sulfur का oxidation state यहाँ पे +4 है, यहाँ पे +2 हो गया. And lead का oxidation state जो +4 है, it converted into +2, which is showing the reducing behavior of SO2. Is that clear? Next, test for SO2, just like test for CO2. CO2 के टेस्ट में हम क्या करते हैं? We pass carbon dioxide through lime water. Whenever I pass carbon dioxide through lime water, it turns milky. CO2 pass through lime water. Lime water is CaOH twice. It turns milky because of formation of calcium carbonate. Okay, this is milky. This on further reaction with CO2, system के अंदर already H2O है, it converts into calcium bicarbonate. Calcium bicarbonate is soluble. Okay, hence that being soluble, जो milkiness है, it disappears. Similar reaction also happens with SO2. Again, lime water, CaOH twice is called as lime water. If I'm passing SO2 through the lime water, initially it is converting into milky. That on further reaction with SO2, it is converting into calcium bisulfite. यहाँ पे calcium bicarbonate आया, that is soluble, hence the milkiness disappeared. Similarly, यहाँ पे calcium bisulfite मिला, which is also soluble, and the milkiness disappears. Exact एक जैसा ही है, SO2 को मिलाने से या CO2 को मिलाने से आपको वही बन रहे. पहले calcium sulfite मिला, which on further reaction with SO2, it is converting into bisulfite. Similarly, यहाँ पे calcium carbonate मिला, which on further reaction converting into bicarbonate, which is soluble. Is that clear? SO2, Cl2 in the presence of water. This being reducing, Cl2 यहाँ पे chlorine का oxidation state 0 है, so it is converting into -1 oxidation state. Sulfur is converting from +4 to +6. Any doubt, anyone? Any doubt? Okay. These reactions, we have seen this in the chapter of D and F block also. SO2 with KMnO4. SO2 with KMnO4. KMnO4 is very strong oxidizing agent. So it converts this into sulfate, and in acidic medium, this converts into Mn2 positive. K2Cr2O7, it converts into SO4 again. SO2 converts into SO4 minus. You need to take sulfur in +4 oxidation state to +6 oxidation state. So हमेशा आपको सल्फेट जैसा मिलेगा. क्रोमियम का यहाँ पे +6 ऑक्सीडेशन स्टेट जो है, +6 it is converting into +3. यहाँ पे Mn का +7 ऑक्सीडेशन स्टेट जो है, it is converting into +2. Any doubt? ClO4 minus, क्लोरीन का +7 ऑक्सीडेशन स्टेट जो है, this being reducing, it is converting into 0 oxidation state. Similarly, IO4 minus में जो +7 oxidation state है, it is again converting into 0 oxidation state. Fe+3 converts into Fe+2. This reaction is important reaction with PCl5. It is converting SO2 into POCl3 and SOCl2. POCl3 can be used as very good dehydrating agent. Okay, it is converting SO2 into POCl3 and SOCl2. बाद में हम देखेंगे SO3 का भी reaction. SO3 reaction with PCl5, SO2 reaction with PCl5. Okay, SO3 में एक ऑक्सीजन ज्यादा हुआ ना, so in that case you will be getting POCl3 plus SO2Cl2. SO2Cl2 splits into SO2 and Cl2. आगे देखेंगे PCl SO3 के साथ reaction. यहाँ तक क्लियर है? Okay. Very less people are attending the lecture. बाकी लोग क्या कर रहे हैं? घर पे ही है ना? Okay, ठीक है. Next. SO3. SO3 में आपको ये पूछते हैं the nature of the bonds. What is the hybridization of SO3 first of all? If you are having sulfur का outermost electron 6 है. All the 6 electrons are participating in bonding, so there is no electron left. Red atoms are sp2. Okay, ठीक है. अभी यहाँ पे आपको पूछते क्या है? The nature of these pi bonds. Remember, सल्फर का ग्राउंड स्टेट कॉन्फ़िगरेशन इज 3s2 3p4. 3s2 3p4 मतलब वैसा कुछ रहेगा where you are having only 2 unpaired electrons. यहाँ पे कितना bonds बन रहे हैं? Having 6 bonds, you need to have 6 unpaired electrons. Okay. So what I'm doing is I will be shifting these electrons into vacant d subshell. So once I'm shifting these electrons, you are getting 1, 2, 3, 4, 5, 6 unpaired electrons. Out of the 6 unpaired electrons, you are having only 3 sigma bonds. You are having 3 pi bonds. A pi bond will always be formed by a pure orbital. Pi bonds can never be formed by a hybrid orbital. So इसलिए यहाँ पे hybridization पे आपको only 3 orbitals को लेके गया because you are having only 3 sigma bonds. Those 3 orbitals will be forming 3 sigma bonds. बचा हुआ 3 orbitals जो है they will be forming pi bonds. Okay. So the 3 orbitals which are left are 1p and 2d. Agreed? एक p है और 2 d है. So you will be having 1 p pi overlap and you will be having 2 p pi and d pi. सल्फर के ऊपर आपको p orbitals और d orbitals भी है. एक p और 2 d है. On oxygen you will be having only p. So you are having 1 p pi and you will have 2 d pi p pi. Is that clear? Okay. The interesting fact is, even though you are having two different overlaps, the bond lengths of all the bonds same. ये जितना होगा, ये उतना होगा, ये भी उतना ही होगा. Is that clear? One more important thing is, whenever SO3 reacts with PCl5, you got SO3, so you have SO2 Cl2. Is that clear? Am I audible? Okay. लैग हो रहा है क्या? अभी ठीक है?
हाँ सर.
Okay. SO2 with PCl5, this reaction is very important, where you are forming POCl3 and SOCl2. SO2 with SO3 with PCl5, again you are getting POCl3. एक ऑक्सीजन ज्यादा है SO3 में, इसलिए यहाँ पे SO2Cl2 बना देना. That SO2Cl2 is breaking into SO2 and Cl2. Is that clear? Okay. There is also trimer structure of SO3, which looks like this trimer structure. And यहाँ पे इसको aromatic भी बना सकते हो. यहाँ पे जो lone pair से, you can give that lone pair in here. In the process, you can break this bond. Okay. It is forming a trimer cyclic structure because of achievement of aromaticity. Okay. ठीक है. Not so significant. ये उतना important नहीं है. ठीक है. These are very important. Acids of sulfur. Everyone. Acids of sulfur, very important. H2SO4, which is called as sulfuric acid, also called as oil of vitriol or king of chemicals. H2SO3, called as sulfurous acid. H2SO2, यहाँ से एक ऑक्सीजन को हटाया हमने, hence it is called as hyposulfurous acid. If you are having lesser amount, it is called as hypo. If you are having more amount, it is called as hyper. As it is having one oxygen less, it is called as hyposulfurous acid. Then you have H2SO5, which is called as Karos acid. H2S2O8, which is called as Marshall's acid. Both of these acids have peroxy linkage. Okay, you have peroxy linkage. Peroxy linkage matlab you will be having oxygen-oxygen bond. This is called as peroxy linkage. Then you have H2S2O7, also called as oleum. जो H2S2O7 है, let us see how we can make that formula. If I take H2SO4, which is called as sulfuric acid, उसको 2 times multiply करो, you will get H4S2O8. Remove H2O from this, minus H2O. What will you get? H2S2O7. यही तो मिलेगा, which is oleum. So multiplying sulfuric acid by 2 and removing a water from it, can I say, I can call oleum as pyrosulfuric acid. Pyro matlab heat. Whenever you are heating, you will be removing water molecule. Hence, this oleum is also called as pyrosulfuric acid. Is that clear? Okay, next. H2S2O3, it is called as thiosulfuric acid, and Na2S2O3 is called as sodium thiosulfate, hence it is called as thiosulfuric acid. H2S2O5, it is called as pyrosulfurous acid. Pyro matlab heat. Sulfurous acid is H2SO3. 2 से मल्टीप्लाई किया तो आपको क्या मिलेगा? H4S2O6. If you remove H2O from this, what will you get? H2S2O3. Sorry, H2S2O5. Is that clear? H2S2O5, which is nothing but pyrosulfurous acid. Okay. Then you have a set of acids called Ionic acids. This is not Diatonic, it is Diatonic. Correct in your notes, it is Diatonic. Okay. H2S2O6 is called as Diatonic acid, where you are having an SS linkage. In case of phosphorus acids, name the phosphorus acid which has a PP linkage. Sorry, I can't hear you, Shiv Prasad. Name the phosphorus. Still, I can't hear you.
Pyrophosphoric acid.
Sorry?
Pyrophosphoric acid.
Pyrophosphoric acid. Pyrophosphoric acid नहीं है, उसमें तो PP linkage नहीं रहेगा. It is not pyrophosphoric acid. It is hypophosphoric acid. It is hypophosphoric acid. दो phosphoric acid molecules में से दो OH हटाएंगे. Remove two OH rather than removing H2O. Pyro मतलब you will be removing H2O. In hypophosphoric acid, you will be removing two OH. H3PO4 का twice किया तो you will get H6P2O8. H6P2O8 से दो OH हटाना. H4P2O6. H4P2O6 is the hypophosphoric acid which has a PP linkage. Is that clear? Everyone? Okay. Dithionic acid. Thionic acids. All thionic acids will be having SS linkage. Dithionic acid मतलब you will be having two sulfurs, उनके बीच में SS linkage. Trithionic acid मतलब you will be having three sulfurs, उन सबके बीच में एक SS linkage. देखते हैं. Everyone in the lecture? Okay. H2SO4 important है. H2SO4 के reactions भी important है. H2SO4 is also called as oil of vitriol or king of chemicals. It is a strong acid. It readily dissociates into 2H positive and SO4 2 minus. But if you want to show that as two different dissociations, you can treat that as पहले K1 से HSO4 minus में convert हुआ, K2 से SO4 2 minus में convert हुआ. Or if there is sufficient amount of water, the entire amount of H2SO4 will be converting into 2H positive and SO4 2 minus. अगर sufficient amount नहीं है तो पहले H2SO4 HSO4 minus में convert होगा. That HSO4 minus will be converting into SO4 2 minus. Is that clear? Okay. Structure में I hope every one of you can draw the structure. The important thing is the bond angle between the two double bond is greater to the bond angle. Important है. यहाँ पे ये जो bond angle है, it is greater when compared to this bond angle. Remember that. Is that clear? I hope you can get hybridization. I hope you can get the oxidation state. The important reactions of H2SO4 are studied in three different categories. One as a dehydrating agent. H2SO4, HNO3 are very, very good dehydrating agents. Okay. So we will be studying the reaction of H2SO4 as a dehydrating agent, as an acid, because H2SO4 is an acid, and as an oxidizing agent. Oxidizing agent मतलब खुद reduce होगा. Again, HNO3 का भी oxidizing agent का reactions बहुत रहता है. We will be seeing the reactions of H2SO4 in three different sets: as a dehydrating agent, as an acid, as an oxidizing agent. Let's see the preparation method. The preparation method of H2SO4, it is called as contacts process. For that, you need to have SO2. That SO2 is prepared by heating sulfur in the presence of oxygen. Sulfur plus oxygen आपको SO2 मिल जाएगा. That sulfur which is used for the preparation of SO2, it is obtained by a process called Frasch process. Okay. ठीक है. ये इसके लिए अलग से एक नाम ही है हमारे पास. We don't have any other information other than that. Frasch process. Okay. So sulfur, whenever you are heating that in air, you will be getting SO2 and some traces of SO3. That SO2, if it is further reacted with O2 in the presence of B2O5 catalyst, it converts into SO3. अब ये SO3 जो है इसको डायरेक्टली पानी में डाल दिया तो आपको H2SO4 मिल जाएगा. Okay, but we don't do that. What we do is we will be reacting this formed SO3 with already existing H2SO4 solution, which is also called as stock solution. Okay, stock solution मतलब there is some concentration of that particular H2SO4. उसको जब SO3 के साथ react कर रहा हूँ, it is converting into oleum first. Okay, that oleum, whenever it is dissolved in water, it will be giving you H2SO4. So depending upon the concentration of H2SO4 which you need, यहाँ पे it is 98% weight by volume. Suppose you may not need that particular concentration, you may require some other thing. तब क्या करेंगे? पहले SO3 के साथ react किया तो oleum बनेगा. उस oleum को पानी में डाल दिया तो you will be getting H2SO4 again. So depending upon the concentration you need, accordingly add the amount of water, required amount of water. ज्यादा water add कर दिया तो आपको concentration कम हो जाएगा, कम water रखा तो आपको concentration ज्यादा रहेगा. Is that clear? What you need to remember is once you form SO3, SO3 is formed from SO2 using V2O5. Okay. Once you form that SO3, which is formed from SO2 using V2O5, you can directly put that SO3 in water, which will lead to the formation of H2SO4. But वैसा नहीं करते हैं. We will be taking already prepared H2SO4, okay, which is having certain concentration, 98% weight by volume. Upon treatment of SO3 with this, you will be getting oleum. उस सोडियम को फिर से पानी में मिलाए तो आपको H2SO4 आएगा. यहाँ पे फिर से पानी में मिलाने से you can form different concentrations of H2SO4 depending upon the water content. Water ज्यादा है तो concentration घटेगा. Is that clear? Okay. अब इतना याद रखो. The preparation method used for H2SO4 is contact process, and the catalyst used for the conversion of SO2 into SO3 is V2O5. This catalyst is important. Okay, let us see the reactions of H2SO4 as a dehydrating agent, as an acid, as well as an oxidizing agent. Dehydrating agent मतलब क्या है? आपको H2O हटाना है. Okay. C6H12O6, which is sucrose or glucose. इन दोनों से if I am removing all molecules of H2O, I will be left with only carbon. So you will be forming carbon and carbon. Whenever I am adding H2SO4 to sucrose or glucose, you will be left with carbon. Black substance जैसा ending में रहेगा, which is carbon. Is that clear? The remainder कहाँ तक सुना आप लोग? SO4 is a very good dehydrating agent. ये 3 reactions या यहाँ पे जो भी 5 reactions लिखा है, remember them. Fifth reaction is nothing but dehydration of alcohol, which will give you. तो हम organic में देखा है. These 4 reactions are very very important. Treatment of H2SO4 or treatment of sucrose or glucose with H2SO4. If you are removing water, you will be left with only carbon. Ending में आपको एक black substance जैसा रह जाएगा container के अंदर, which is nothing but carbon with HCOH. Remove H2O. यहाँ से H एक oxygen. If I am removing H2O, you will be left with carbon monoxide. Okay. So this is used as a preparation method of carbon monoxide. वैसा बोल सकते हैं. With H2C2O4. Again remove H2O. यहाँ से H, यहाँ पे O. If I am removing H2O, you will be left with CO2 and CO. So HCOH में आपको केवल carbon monoxide मिलेगा. In case of H2C2O4, which is oxalic acid, इस केस में आपको कार्बन डाइऑक्साइड as well as कार्बन मोनोऑक्साइड दोनों बन रहे हैं. Is that clear? If you are adding blue vitriol, whose color is blue, to H2SO4. Again, that being a dehydrating agent, H2O हटा चला गया तो you will be left with CuSO4. Okay, CuSO4.5H2O में what is the reason for the color? The reason for the color is because of the coordinate bond with 4H2O. Okay, one of the H2O is held with hydrogen bonding. अभी यहाँ पे जो भी H2O है, if all the H2O are removed, okay, if all the H2O are removed, then there won't be any color. Color is because of DD transitions, na? That is because of transitions. Is that clear? Agar if there is no ligand, H2O है ही नहीं, it becomes colorless. Important. This is an important observation. Okay. Next, as an acid base reaction, an acid plus base will give you salt and water. NaOH plus H2SO4, Na2SO4 plus water. NaHCO3 plus H2SO4. This is so base. This is an acid. HCO3 minus जो है converts into H2CO3. H2CO3 being unstable converts into CO2 and H2O. Similarly, H2SO4 with CO3 2 minus. CO3 2 minus will be accepting H positive to convert into H2CO3. Again, this being unstable, आपको CO2 or H2O. Okay. Any active metal with any acid will give you hydrogen gas. यहाँ पे भी वही हो रहा है. Active metal with H2SO4 will get hydrogen gas. NH2 minus plus H2SO4. NH2 minus is the base. H2SO4 is an acid. H positive shift कर दो. You will be getting NH3. Okay. Any doubt? Okay. And ये जो reaction है, it will be predominantly in forward direction. Reason, NH3 is a weaker acid when compared to H2SO4. H2SO4 is a stronger acid. Is that clear? Okay. As an oxidizing agent, HNO3 में भी हमने reactions देखा है. HNO3 का oxidizing agent जैसा पिक्स करके देखा है. Remember, पिक्स मतलब फॉस्फरस के साथ, आयोडीन के साथ, कार्बन के साथ, सल्फर के साथ. यहाँ पे भी पिक्स और Cu. So you can remember this as cute pics. Okay. PICS, remember this as cute. Okay. वहां पे HNO3 के साथ केवल पिक्स के साथ रिएक्शन देखा है, PICS के साथ ही. यहाँ पे कॉपर भी है. Is that clear? What we need to do? HNO3 के साथ क्या किया हमने? We made NO2. So in this case, we'll be making SO2. Okay. Concentrate H2SO4 plus P4SO2, and I am taking them into their higher oxidation states. Phosphorus के साथ zero oxidation state जो है, it is converting into +5. Iodine में the reaction is with I minus, it is not with I2. Okay, but in case of HNO3, we have seen the reaction with I2. Observe the difference. HNO3 के केस में यहाँ पे जो रिएक्शन है, this is reaction with I2, where you obtain HiO3, HiO4 तक लेके नहीं जाएंगे because HiO4 is a stronger oxidizing agent. Okay, यहाँ पे जो भी रिएक्शन अभी जो भी देख रहे हैं हम, the reaction is with I minus but not with I2. Just understand the difference and remember it. I minus के साथ the product is not HiO3, the product is I2 only. यहाँ पे product I2 ही है, it is not HiO3. Is that clear? Okay. कार्बन के साथ again you will be getting H2CO3. जैसे यहाँ पे H3PO4 मिला है, H2CO3 मिलेगा. H2CO3 being unstable, it converts into CO2 plus H2O. Okay. सब में बाई प्रोडक्ट्स क्या होंगे? SO2 ही रहेंगे. SO2, SO2, SO2. जैसे उस केस में NO2, NO2, NO2. With copper, it will be forming copper sulfate. यहाँ पे SO2 नहीं मिल रहा है, यहाँ पे copper sulfate मिल रहा है. Is that clear? Okay. यहाँ पे H2O and with copper sulfate you can add one more product. अगर Cu का ऑक्सीडेशन हुआ तो किसी का रिडक्शन तो होना चाहिए. You'll be getting H2. H2 कहाँ से आया? H2SO4 से आपको H पॉजिटिव आएगा. कॉपर के अंदर से इलेक्ट्रॉन्स आएंगे. 2H positive plus 2 electrons gives rise to H2. Is that clear? Okay. Okay. Let's look at the acids of sulfur. H2SO3, which is called as sulfurous acid. Sulfurous acid. And this is dibasic. If it is dibasic, you need to have two OH groups. So, दो OH है, double bond O. Any doubt? के outermost electrons इनसे में पास होंगे. H2SO3 से you can form HSO3 minus, which is formed from NaHSO3. If you remember, this is used as a test for aldehydes and methyl ketones. Remember, NaHSO3 test for aldehydes and methyl ketones. इससे further H positive हटा दिया तो you will be getting SO3 2 minus, which is called as sulfite ion. Sulfite. This is bisulfite. HSO3 minus मतलब bisulfite. This is going to be sulfite. H2SO4 is sulfurous acid. Okay. Sulfurous acid. If I remove H2O from it, its anhydride is going to be SO2. Okay, और SO2 को पानी में मिला दिया तो आपको H2SO3 मिलेगा. If I am removing one oxygen from H2SO3, we get into SO8, H2SO2. If this is sulfurous acid, this will be called as hyposulfurous acid because एक oxygen कम है ना. Hyposulfurous acid, जिससे जो भी आयन मिला है, it is called as hyposulfite. Okay, hyposulfurous acid, hyposulfite. Any doubt? Okay. This is also dibasic. If it is dibasic, आपको दो H groups रहेंगे. सल्फर का outermost electrons 6 है, दो bonds बना, so you are left with 4 electrons or 2 lone pairs. Not so important acid, H2SO2. मतलब बन सकता है करके बोल रहा हूँ. This is not so important. This is very important, H2SO5, which is called as Karos acid or persulfuric acid or peroxomonosulfuric acid. Per indicates you will be having a peroxyl linkage. मतलब oxygen के बीच में bond रहेगा. So H2SO4 का structure draw करके, rather than having OH attached to oxygens, have a peroxyl linkage. Okay. This is Karos acid. Whenever I treat H2SO5 with water, it converts into H2O2 and H2SO4. We have seen in the chapter of electrochemistry. Electrochemistry में H2SO5 बनाया है. H2SO5 on dissolution in water, it converts into H2SO4 and H2O2, which is used as a preparation method for H2O2. Remember, electrolysis of acidylated water, okay, using high charge density. Low charge density पे नहीं होगा. Low charge density पे it is like electrolysis of water only, where you will be getting H2 and O2. Electrolysis of water is H2 and O2. High charge density पे you will be getting H2O2. So this is used as a preparation method of H2O2. Okay. And ये जो Karos acid है और peroxy acids जो है, in organic chemistry it is used in different reactions. Anti-morphonic oxidation of HBr. Remember? Okay. And then epoxides, epoxidation के लिए, okay, Bayer vinegar oxidation के लिए, and in ozonolysis, if you want to do oxidative ozonolysis, हम H2O2 use करते थे. You can use also H2SO5 because it is also peroxy acid. Okay, H2O2 भी use कर सकते हैं, or you can also use H2SO5. Is that clear? Okay. Next, Marshall's acid, which is peroxo disulfuric acid. मतलब दो सल्फ्यूरिक एसिड मॉलिक्यूल्स के बीच में आपको एक पेरोक्सी लिंकेज लगाना है. Okay, so this is also a peroxy acid. Whenever this is dissolved in water, it converts into H2SO4 and H2SO5, which on further dissolution in water converts into H2O2. Is that clear? Everyone? Okay. Next, H2S2O7, which is also called as oleum, which is also called as fuming sulfuric acid, represented by H2SO4 dot SO3, also called as pyrosulfuric acid. Pyro matlab heat, सल्फ्यूरिक एसिड मतलब दो सल्फ्यूरिक एसिड मॉलिक्यूल्स के बीच में H2O हटाना है हीट करके, then you will be forming this structure. Formation of the structure is easy once you know how to draw the structure of sulfuric acid. This is structure of H2SO4. ऐसा दो सल्फ्यूरिक एसिड मॉलिक्यूल्स को आमने सामने रखो, then remove H2O. If I am removing H2O, I will be forming this structure. In case of pyro acids, हमेशा जब भी pyro acids रहता है, you will be having a non-metal, an oxygen and a non-metal linkage. Non-metal, oxygen, non-metal linkage. ये हमेशा रहेगा कोई भी pyro acid में. Okay, pyrosulfuric acid, pyrophosphoric acid, pyrophosphorus acid, pyrosulfurous acid, कोई भी acid में वो रहेगा. Next, H2H2O3, which is also called as thiosulfuric acid, Na2H2O3, which is called as thiosulfate. Thio matlab, if you are replacing one of the oxygen by sulfur, it is called as thio. Sulfuric acid is H2SO4. H2SO4 में से H2SO4. If I replace one of the oxygen by sulfur, I'll be getting H2. Sulfur एक ज़्यादा हो गया, oxygen एक कम हो गया, H2H2O3. Is that clear? So it is thiosulfuric acid, which is also a dibasic acid. मतलब it can give 2 H positive. एक H positive देके HH2O3 minus में convert होगा और एक H positive देके H2O3 2 minus में convert होगा. उसका ये salt sodium thiosulfate. Everyone concentrate here once. ये important है. Sodium thiosulfate reactions with different halogens. Sodium thiosulfate. The reaction of sodium thiosulfate with different halogens. Chlorine के साथ, bromine के साथ, iodine के साथ. With iodine, it is forming sodium tetrathionate. This is called as sodium tetrathionate. With Br2, you are forming sodium sulfate. With Cl2, you are forming sodium bisulfate. Okay, whenever you have hydrogen, it is called as sodium bicarbonate, sodium bisulfate. Okay, so with I2, it is forming sodium tetrathionate, which is used as an estimation reaction of I2. Okay, which can further be used as an estimation of O3. Remember? Okay, ठीक है. These three reactions are very, 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 very important. Direct question आपको पूछ सकते हैं. Na2H2O3 with I2, with Br2 and with Cl2. Remember, अलग से products याद रखना है. यहाँ पे bisulfate मिल रहे, या सब में Cl minus, Br minus, I minus मिल रहे, but other products bisulfate, sulfate, tetrathionate. Is that clear? Any doubt, anyone? Okay. Thiosulfuric acid का structure draw किया है. If you are having SH, you can also have OH. OH भी रह सकता है, SH भी रह सकता है. Last lecture में हमने बात किया है. If you are having SH, this will be a stronger acid because for the elements belonging to same group, you need to see the size. Greater the size, less will be the bond energy. H positive easily आ सकता है. Okay. So if you are having SH, it will be more acidic. But if you want to draw the more stable structure, OH के साथ draw किया तो this will be more stable structure. Okay. If you are having S double bond S, reason क्या होगा? यहाँ पे जो linkage रहेगा, sulfur orbitals, इन दोनों के बीच में pi bond जो है, वो ज़्यादा effectively बनेगा when compared to the pi bond between oxygen and sulfur. As a result, this becomes more stable structure. But if they're asking about which structure leads to more acidic character, this is the structure. क्योंकि S bond H जो है, it is weaker when compared to this O bond H. Is that clear? Okay. Next, pyrosulfurous acid. सल्फ्यूरस एसिड मतलब क्या हो गया, H2SO3 हो गया। पायरो मतलब इसके दो मॉलिक्यूल्स से, विच इज H4H2O6। वी विल बी रिमूविंग H2O। H2O हटाया तो आपको H2S2O5 बनेगा, विच इज पायरोसल्फ्यूरस एसिड। सल्फ्यूरस एसिड इज ऑल्सो डाइबेसिक एसिड। H2SO3 है ना, तो यहाँ पे एक OH, यहाँ पे एक OH। सिमिलरली फॉर्म अनदर मॉलिक्यूल, दोनों को आमने सामने रखो। व्हाट यू नीड टू डू, I need to remove H2O. If I remove H2O, I will be forming this. Any pyro acid will be having non-metal oxygen non-metal bond. Non-metal oxygen non-metal bond. There is one more structure that is proposed for pyrosulfurous acid, which is this. So take a note of this as well. Important here. In this structure, the oxidation state of sulfur is +4. यहाँ पे भी +4 है. The average is also +4. In this structure, the oxidation state of sulfur is एक +3 है, दूसरा +5 है. Is that clear? Okay, एक +3 है, दूसरा +5 है. याद रखना, यहाँ पे क्या किया हमने, दो सल्फ्यूरस एसिड मॉलिक्यूल से एस डबल बॉन्ड हो. Okay, you are having an SS linkage. What is the difference between these two? यहाँ पे आपको नॉन मेटल और नॉन मेटल लिंकेज है, यहाँ पे आपको SS लिंकेज है. दिस इज ऑल्सो, रिमेंबर दिस इज ऑल्सो डाइबेसिक, मतलब 2 H पॉजिटिव दे सकता है. दिस स्ट्रक्चर इज ऑल्सो डाइबेसिक, इट कैन ऑल्सो गिव 2 H पॉजिटिव. सो एक OH लगा देना आप लोग एंड रिमेनिंग ऑफ द ऑक्सीजन्स फिट कर लेना. ओके, the only thing you need to remember to form this structure is it is having an SS linkage. If it is having an SS linkage, it is also a dibasic. Dibasic मतलब आपको 2 OH दिखना ही चाहिए. So OH लगा लो, बचा हुआ ऑक्सीजन को डबल बॉन्ड्स के साथ सेटिस्फाई कर लेना. Is that clear? बट अगर आपको एग्जाम में पूछा है मार्क दिस एज द वैलिड स्ट्रक्चर, ये दोनों स्ट्रक्चर्स दिया ऑप्शंस में, मार्क दिस एज द वैलिड स्ट्रक्चर, तो मतलब हीट करने से आपको H2O हटाना है. ओके, एडवांस्ड में अगर कुछ अलग तरीके से पूछा तो देन थिंक अबाउट दिस स्ट्रक्चर टू, ओनली फॉर एडवांस्ड. इज दैट क्लियर? ओके, नेक्स्ट थायोनिक एसिड्स. यहाँ पे फिर से स्पेलिंग करेक्ट कर लेना, इट इज नॉट डाइथोनिक, इट इज डाइथायनिक. यहाँ पे भी पॉलीथायनिक एसिड्स. In all thionic acids, you will be having SS linkage. Dithionic मतलब you have 2 sulfurs. Okay, trithionic मतलब आपको 3 sulfurs रहेंगे. Tetrathionic मतलब 4 sulfurs रहेंगे. सल्फर के बीच में linkage and all thionic acids are dibasic. Dibasic मतलब आपको 2 ही OH रहेंगे. Okay, so सल्फर के बीच में bond OH, बचा हुआ ऑक्सीजन डबल बॉन्ड O के साथ. Is that clear? ट्राइथायनिक मतलब आपको 3 सल्फर, टेट्राथायनिक मतलब आपको 4 सल्फर, पेंटाथायनिक मतलब आपको 5 सल्फर, so on so forth. Is that clear? Okay, thionic acids में there will be SS linkage. Dithionic acid में आपको 2 सल्फर्स रहेंगे. ट्राइथायनिक एसिड में आपको 3 सल्फर्स रहेंगे, तीनों के बीच में बॉन्ड. टेट्राथायनिक के बीच में आपको 4 सल्फर्स, 4 के बीच में बॉन्ड. Is that clear? Okay. This is about all acids of sulfur. Okay. We are left with the last parts, group 17 and group 18. Group 17 and group 18. Let's start group 17. If you want, you can take 2 minutes break. 2 minutes break लेना, we can start with group 17. Okay. Okay. Group 17, halogens. General configuration is NH2NP5 you need to know the states of all different elements present in it. Fluorine is also because of weak van der Waals forces, they're gases. Down the group, as the size increases, the van der Waals forces is going to increase. Down the group, size भी बढ़ता है, as well as molecular weight also increases. Van der Waals forces जो है, they are function of size and molecular weight as well as number of valence electrons. If the number of valence electrons are more, then also you can have more and more induction of charges. If there are more induction of charges, van der Waals forces ज़्यादा रहेंगे. Agreed? Okay, so down the group, as van der Waals forces are increasing, they're converting from gaseous state to liquid state, and then from the liquid state to solid state. Astatine is radioactive, so इसके बारे में हम discuss नहीं करेंगे. Fluorine is a gas, chlorine is a gas, bromine is a volatile liquid, iodine is solid. The colors, you need to remember the colors as well. Fluorine has yellow color, chlorine has yellowish green, bromine is reddish brown, and then iodine is violet. Okay. I hope आपको सब लोगों को bromine और iodine इनके colors तो पता ही है. Iodine is violet and bromine is reddish brown. Both of these are yellowish in nature. Fluorine is yellow and chlorine is yellowish green. Down the group, atomic size increases. Down the group, ionization energy decreases as you go away from the nucleus. The effect of the nucleus on the outermost electron decreases. As a result, the ionization energy decreases. Electronegativity, सबके values आपको याद करना है. Fluorine is the highest electronegative element, so इसके लिए 4 है. Then chlorine is 3. The electronegativity of chlorine is almost similar to that of nitrogen. And chlorine is, अगर exact values compare किया तो chlorine का ज़्यादा ही रहता है. Chlorine is slightly greater than nitrogen. Okay. Bromine is 2.8, iodine is 2.6. Electron affinity के comparison में, this is very important order. Electron affinity का order as well as bond energy का order, bond dissociation energy. Down the group, as you go away from the nucleus, the electron affinity has to decrease, or fluorine should be having the highest electron affinity when compared to chlorine, then bromine, then iodine. But actual में order, chlorine is becoming highest when compared to fluorine. The reason is, in case of fluorine, the electron is added to second shell. Okay, second shell में add करने की वजह से experiences greater repulsions. Experiences greater repulsions due to existing electrons. Okay. Fluorine के case में, the electron which I am giving that in the second shell. Second shell being smaller, the incoming electron will be experiencing greater repulsive forces when compared to the chlorine. Chlorine में वो जो electron दे रहे हैं हम, it will be given in the third shell. Okay. Because of that, fluorine has greater electron affinity when compared to chlorine. Sorry, chlorine has greater electron affinity when compared to fluorine. Is that clear? Everyone? शिव प्रसाद हो ना तुम, सो तो ना? Okay. What is the order of electron affinity? ये क्वेश्चन आपको डायरेक्ट आएगा नीट वाले स्टूडेंट्स को और जेईई मेंस के लिए भी. Chlorine greater than, fluorine greater than, bromine greater than iodine. What is the reason for that? In fluorine, the electron is given in the second shell. Because of that, it will be experiencing greater repulsive forces. As a result, the electron affinity slightly decreases when compared to chlorine. Bond energy के data में, down the group, as bond length increases, bond energy has to decrease. This is the expected order. मतलब fluorine should be having the highest bond energy. But यहाँ पे देखो आपको, fluorine जो है, it is having bond energy lesser when compared to bromine. Chlorine से भी कम, bromine से भी कम. Again, the reason is, in fluorine, between fluorine, you are having 3 lone pairs. The size being smaller, the lone pair repulsions are greater in this case. As a result, the bond energy decreases. फ्लोरीन फ्लोरीन दोनों छोटे होने की वजह से ये जो लोन पेयर से सब में 3 लोन पेयर से, बट बाकी जो है क्लोरीन ब्रोमीन आयोडीन, those having greater sizes, the electrons will be far from each other or the repulsive forces will be relatively less. फ्लोरीन के केस में atom being smaller, the lone pairs will be closer. As a result, lone pair repulsions जो भी रहेंगे, those will be dominant and the bond energy decreases. Just remember the order, very very important. Chlorine, bromine, उसके बाद fluorine and iodine. Is that clear? Okay. Reaction with hydrogen, all of them will be forming acids, HF, HCl, HBr, HI. HF जो है, it can exist as a dimer because of formation of hydrogen bond. Okay, it exists as H2F2, HF. Down the group, the acidic strength increases because whenever you compare any property for the elements belonging to same group, size is the dominating factor. As the size increases, bond energy decreases. If the bond energy decreases, H positive can be easily removed, or else the acidic strength increases. Is that clear? Okay. In case of oxy acids or oxo acids, fluorine can form only hypofluorite, but rest all others are able to form, देखो, they are forming hypohalous acid, halous acid, okay, यहाँ पे hypoiodous acid, which is also called as halous acid. If it is chlorine, it is chlorous acid. Iodic acid, which is HiO3, or chloric acid, which is HClO3. Periodic acid, this is not periodic, it is periodic. Periodic acid, which is HiO4. Okay. So, fluorine को छोड़ के बाकी सब जो है, they are able to form different types of acids: hypohalous acid, halous acid, halic acid, and perhalic acid. Fluorine जो है, it is able to form only single type of acid, which is hypohalous acid or hypofluorous acid. Is that clear? Okay. Oxidizing behavior में chlorine is very strong oxidizing agent because it has the highest electronegativity. Okay, oxidizing agent मतलब खुद reduce होगा. So fluorine, whenever it is reacting with water, it converts into fluoride along with formation of O2 and O3. Okay, very strong oxidizing agent. मतलब यहाँ पे ऑक्सीजन को भी ऑक्सीडाइज कर पाया. ऑक्सीजन को क्यों ऑक्सीडाइज कर पाया? Because fluorine is the strongest oxidizing agent or fluorine has highest electronegativity. Okay, ऑक्सीजन के अंदर से भी इलेक्ट्रॉन निकाल पाया वो because fluorine has the highest electronegativity. Chlorine, whenever it is dissolved in water, अभी आपको रिएक्शन दिया है, it will be forming HOCl as well as HCl. If it is dissolved along with NaOH, it will be forming NaOCl and NaCl. Remember? Okay. Br2 with water, again similar reaction हुआ है, HBr plus HOBr. I2 plus water, there is no reaction. Okay. अगर आप लोग okay, बाद में देखते हैं. With I2 and water, there is no reaction. With normal water, it is converting into hypohalous acid. If it is along with NaOH, it will be reacting with that NaOH to form NaCl as well as NaOCl, which is sodium hypohalite. Again, this is a disproportionation reaction. Any doubt? Okay. The oxidizing strength F2 greater than Cl2 greater than Br2 greater than I2. This is based on their electronegativity as well as based on the hydration. जो oxidizing agent strength, reducing agent strength जो भी है, they are determined in aqueous solutions. If they are determined in aqueous solutions, you need to concentrate on hydration as well. Is that clear? Everyone, please put a video on. Is that clear, everyone? Okay. Oxidizing agent strength F2, Cl2, Br2, I2. Acidity HF less than, HCl less than, HBr less than HI. Hydrogen bonding HF greater than, down the group it decreases. Dipole moment, charge is the more dominating factor. As charge is more dominating factor, HF greater than or down the group it decreases. Dipole moment. Reducing agent strength. Okay. Down the group the reducing nature increases. Down the group the reducing agent nature increases. HI is a stronger reducing agent. Okay. हमने ऑर्गेनिक में भी पढ़ा है. HI is the strongest reducing agent. Down the group reducing agent strength increases, मतलब HF less than, HCl less than, HBr less than HI. HF is very very weak reducing agent क्योंकि वो खुद ऑक्सीडाइज नहीं हो पाएगा, फ्लोरीन being highly electronegative element. Is that clear? Okay. Boiling point में boiling point order HF सबसे ज्यादा है, reason because of hydrogen bonding. Okay, and down the group, as you are having increase of van der Waals forces, the boiling point is going to increase. मतलब HF सबसे ज्यादा है because of hydrogen bonding. उसके बाद HI रहेगा, उसके बाद HBr, then HCl. Is that clear? Expected क्या रहेगा? HF less than HCl less than HBr less than HI. But HF सबसे ज्यादा क्यों हो रहे? Because of hydrogen bonding. If you see melting point में HI is greater than HF. Even though there is hydrogen bonding, in case of melting point, you need to also see about packing. Okay. Packing में HI has a better packing because of which उसका melting point सबसे ज्यादा होता है. Remember this. अलग से order याद रखो. There is an exception here. We expect HF to have stronger or higher melting point too, but उसका melting point थोड़ा सा कम है HI के comparison में, because apart from hydrogen bonding, you also need to see packing. Is that clear? Okay. Next, oxo acids of halogens. Apart from fluorine, rest all other are able to form hypohalous acid, halous acid, halic acid, and perhalic. Okay. So you have HOI or HIO, HIO2, HIO3, HIO4. यहाँ पे मैंने I'm writing the strength of the acids. HIO3 is greater than, sorry, HIO4 is greater than, HIO3 is greater than, HIO2 greater than HIO. The reason is H positive हटाते ही the negative charge can be stabilized on 4 oxygens because of resonance. यहाँ पे 3 oxygens, यहाँ पे 2 oxygens, यहाँ पे एक ही oxygen. Okay, this is the order of acidic strength of different acids of the same element. If I am seeing order of acidic strength of different acids of different elements, मतलब iodine का, Br का, chlorine का. Okay, down the group as the size increases, in case of oxy acids, down the group as the size increases, the acidic strength decreases. मतलब HClO4 सबसे strong है. The reason is if I am forming double bond O, double bond O, double bond O, bond O, means if I am forming the conjugate base, इन दोनों के बीच में resonance effectively होगा because the orbital sizes are almost similar. यहाँ पे 2p, यहाँ पे 3p है. This is having a better resonance when compared to Br में orbital size और बड़ा हो जाएगा, so resonance effectively नहीं हो पाएगा. Iodine में orbital size और भी बड़ा होगा, effectively नहीं होगा. इसलिए इनमें HClO4 is the highest, followed by HbRO4, followed by HiO4. Is that clear? Very very important. इनमें again HClO4 will be a stronger acid when compared to HClO3, HClO2 and HClO. इनके anhydrides को भी बनाया है. HClO4 से पानी हटा दो. You cannot directly remove H2O, so multiply this by 2 and then remove H2O. You will be getting Cl2O7. Multiply this by 2, remove H2O, you will get Cl2O5. Multiply this by 2, remove H2O, you will get Cl2O3. Multiply it by 2, remove H2O, you will get Cl2O. Is that clear? एक important point है यहाँ पे. F2O, it is not considered as anhydride of HOF. Reason being, इन सबको पानी में मिलाए तो आपको HOCl, HClO2, HClO3 ये सब आएंगे. But F2O को पानी में मिलाए तो आपको HOF नहीं मिलता है. Hence, it is not considered as, hence not an anhydride of HOF. Is that clear? Okay. Okay. F2O, it is thermally more stable than O2F2. एक extra point लिखा है. Remember this. Arrange all the acids in increasing order of the acidic strength. I hope you can do that. HClO4, HbRO4, HiO4. यहाँ पे दिया है ना. Down the group, as the size of central atom increases, acidic strength decreases. That is in case of oxy acids. But ये जो acid है, this is a hydra acid. यहाँ पे down the group, as the size increases, acidic strength increases. यहाँ पे उल्टा होगा. Oxy acids से अलग है, hydra acids में अलग है. Group में. In case of oxy acids, down the group acidic strength decreases. In case of hydra acids, down the group acidic strength increases. याद होगा? Okay, thermal stability. Whenever you are comparing thermal stability, if you are having a complex anion, if you are having, अभी यहाँ पे HClO4, HbRO4, HiO4. This is the complex anion case. Okay, complex anion के केस में H positive है, ClO4 minus, H positive, BrO4 minus, H positive, HiO4 minus. As the anion size increases, what will happen to covalent character? Thermal stability in case of complex anions, पहले ये याद रख लेना. Already समझाया मैं आपको last lecture में. Complex anions के केस में you will be comparing based on covalent character. As covalent character increases, thermal stability decreases. Okay. As the anion size increase, what will happen to covalent character? Fazan's rules के हिसाब से, as the anion size increase, what will happen to covalent character? Increases. Everyone in the lecture सुन रहे ना? As the anion size increases, मतलब छोटा कैटियन ने अगर anion बड़ा है तो क्या होगा? इसका इलेक्ट्रॉन इसके पास में रहेगा, so this will be more and more polarized. Agreed? So as the anion size increases, covalent character increases. So यहाँ पे HiO4 has more covalent character, hence its thermal stability is least. Okay, thermal stability का order. This is based on covalent character. Any doubt? Any doubt? Okay. And acidic strength order, HClO4 greater than HClO3 greater than HClO2 HClO. Thermal stability का भी वही order है. यहाँ पे size के हिसाब से compare नहीं कर पाएंगे क्योंकि all of them are having different atoms in them. Just remember the same order is for thermal stability, the same order is for acidic character. Okay. Next. There is a question given here. Litmus है. Whenever it is treated with A, the litmus paper is converting into blue. Initially, it further converts into red, and finally it is converting into colorless. Okay. CaOCl2. The answer for this is CaCl2. The reason is CaOCl2, it is basic. So पहले blue में convert हुआ. Whenever it splits or whenever it is dissolved in water, it converts into ClO minus plus Cl minus. Okay. ये जो HCl है, यहाँ पे Ca2 positive ions जो है, they will be reacting with water. उनका hydrolysis okay, will be forming CaOH twice plus H positive. So this is responsible for the conversion of this particular blue color to red. Okay. Whenever you have acidic solution, the litmus will show red. Whenever you have basic solution, the litmus will show blue. Agreed? So initially, पहले इसको मिलाते ही, it is converting into blue. Later, it is converting into red. Why is it converting into red? Because of hydrolysis of Ca2 positive. Ca2 positive पानी से मिलके COH twice और H positive आ रहे. Because of that, it is converting into red. But after some point of time, it is converting into colorless. That is because of bleaching action of OCl minus. Okay, this is nothing but bleaching powder. CaOCl2 जो है, इसको bleaching powder बोलते हैं. So ये जो OCl minus है, hypochlorite, it is having bleaching action, hence it is converting into colorless. Is that clear? CaOCl2 का और एक important reaction, यहाँ पे NaOCl या CaOCl2 दोनों दे सकते हैं. Okay, whenever I am reacting that with ketone, this is methyl ketone na? Methyl ketone, it will give haloform reaction. Converts into, this particular part converts into CHCl3 and the remaining part converts into carboxylic acid. Agreed? Okay. Oxidizing power. Acidic strength का order is HClO4 greater than, HClO3 greater than, HClO2 greater than, HClO. Acidic strength मतलब H plus देगा, H plus दिया तो it can accept everyone. Remember it this way. The one which gives H positive, okay, if it is accepting electrons, it will be converting into H2. Whenever there is liberation of H2, it can be treated as a reducing agent. If it is a strong acid, इसके अंदर से H positive आएगा, and H positive can accept electrons, which will give you H2. Okay, that H2 will be acting as reducing agent. So this being strong acid, इसका reducing agent nature ज़्यादा रहेगा. Okay, oxidizing agent और oxidizing power क्या होगा? कम होगा. So what is the order of oxidizing power? HClO greater than, HClO2 greater than, HClO3 greater than, HClO4. Very, very important order. Direct question आएगा. Oxidizing agent strength, HClO greater than, HClO2 greater than, HClO3 greater than, HClO4. Is that clear?
Yes.
Okay. ठीक है, यहाँ तक ही करते हैं. We'll stop here. I will take one more lecture anytime. I will complete this preparation methods of halogens. And starting में general properties of group 15. We will complete that later. Okay.